that it's cutting edge. It's exciting. Knowing that we're actually making a difference, our work is actually going to be used.
Brent Giesbrecht is one of several students at the University of Regina who are working on an international physics experiment called GlueX. Professor Zizis Papandreou describes the goal of this project.
In subatomic physics, we are concerned with understanding the fundamental aspects not only of the constituents of matter, basically everything that we see around us is formed by certain fundamental building blocks, but also by how these interact between them, and specifically what is the glue that binds them together that allows us to basically have buildings, people, animals, etc.
He says theoretical modeling of matter predicts a binding particle called a gluon. The only way to prove this theory is to use sophisticated detector systems. Professor George Lolos also works on GlueX.
We have been given the responsibility to build the most expensive, the largest, and the most critical component of the experiment. That's the barrel calorimeter. And that actually shows the impact of the University of Regina group in GlueX.
At this stage, the project involves preparing lead and testing thousands of fibers for energy output, but in the near future it will be one piece of a 350-ton puzzle at Jefferson Lab in Virginia.
A calorimeter is a device for measuring energy, and there's going to be a reaction going on the inside. They're colliding particles at high speeds, and what we're building is something that's going to go around it and measure the output energy of the particles.
By tracking the passage and momentum of high-energy particles through layers of lead and fiber, physicists can identify what kind of particle it is and where it came from. Senior PhD student Blake Leverington says his time working on GlueX has taught him how to be a scientist.
You're not really instructed to do anything because nobody really knows what the next step is. So it's kind of, you have to sit down, figure out what the problem is, and then beat your head against the wall for a few years trying to figure out how to solve it. So
why study subatomic physics?
Because it addresses the very issue of what the universe is made of and why is the universe the way it is. So it's pure science, I think, at its best.